Don here in Florida. We're into part 2 of thanks Jeff for helping me out with this lathe. Part 2 is the VFD in the electrical portion that I did with it. In the last segment I talked about how the top end of this machine was actually really in great condition. I probably repeated myself one too many times, sorry for that. But as good as the top end of this machine was, the bottom was just horrific. So what we're going to do is we're going to go ahead and show y'all what I did to put a VFD in this thing, and hopefully we can ease some of the worries that others may have about possibly converting to VFD, because honestly it's dead simple. Okay, so let's go ahead and get these covers off and take a look inside. I'll go ahead and bring this camera up here so we can get a view of that when we're inside. Two. Hey, where'd that come from? All right. Let me get some light on here as well. Light always helps. For those of you that do have 10 double E's, this was probably one of the best modifications I made right here. Putting these ball valves in. I put one here and one up here to make it easier to change and drain the fluids in the gearbox and the spindle head assembly. My original line here was broken. It was cracked right there. When I went to take the cap off, I broke it more, so I had to replace this. And in the process I decided, you know what, the easier it is to make your machine to maintain, the more you're going to want to do it. And one thing I've found is sometimes when these caps are on for a long time, they do want to put a lot of stress on the threads. So to get rid of that problem and just to keep oil off of me, I just put these ball valves on the end. The caps are just on here finger tight. That's all they really need to be. And they're just kind of a backup. I don't ever think those ball valves would leak. But the caps are nice to have on there just in case. The top end of the gear train here, it was all fine. The belt was even in good condition. I did have to buy belts here. The bottom end though was just atrocious. The gearbox, the 2-speed right here, was just a mess. It was just torn up. This pulley here, it was busted. It was cracked out here and on the bottom side. I don't know if maybe that had happened with the back cover that I brazed up. It might have happened all at the same time. Maybe somebody hit it with a forklift or something. God knows what could have happened. Luckily, I was talking to Rim Canyon on Practical Machinist, and he had some of these, and I managed to get this one from him. When I got it, I had to modify it slightly so that it would sit in closer to the gearbox. That was nothing. I just turned probably 1/8 an inch off the back of it. I also went ahead and put some pulling points here in case I ever have to take it back off there, because it is on there pretty tight. And I'd rather have some points that I can pull on, if nothing else, if I need to take it back off that shaft. The belts were missing. Those are A85 belts. You can get them right at any auto parts store. The pulleys on top were fine. The bearings in the idlers, they're not really noisy, but I bought some anyway. I haven't put them in yet, but it's just nice to know that I have them. Like I said, the gearbox I had to go through. The gears in them were pretty tore up. A lot of hand filing and just massaging on those gears to get them to mesh nicely. It took some time. I had to make a new shaft, shifting shaft through there. The tapered pins that were through there, I just got rid of the tapered pins, went straight to bolts, and then cinching bolts behind them. So everything's nice and tight in there. shifts beautifully now. I put all sealed bearings in it, so the only need for lubricant in there is for the gears when you're in back gear. In direct drive, you don't even need lube for that because you're simply coming right off the motor right straight through to the front. It's just a simple lockup. So when you're in back gear, that's the only time you actually really need lube on this now. I guess we'll start right here from the front. The VFD, I'm going to go ahead and put this down here. The VFD, which is where most people kind of get locked up at, is a Huanyang from China. Now when I got this unit, there were no switches here, nothing. All this was gone, and normally there's a bar here with a case and all your switches and stuff completely gone. All the wires were cut. So basically I had a MG that was floating around in the back, lacked any of the electrics up here, and I wasn't even sure about the Reliance motor itself. It didn't really look good. Interestingly enough, there was a 220 to 440 transformer up in where the pump housing is, and it was somehow wired into this, and I don't know what that was all about because that was a single phase, that wasn't a three-phase. With the Huanyang, it's very simple. I showed you the wiring coming in on the side down here, okay? So I've wired it in so that I have my receptacle back here and the cable coming over and up and through and into the Huanyang down here. So you have the input, hot, neutral, and then a ground, so that's in there. And then going out, because I have a three-phase motor in here, you have your three phases going out and straight to the motor. That's really all there is to it. The additional stuff that you have, in my case, is I have a braking resistor right here, and this is probably a little overkill. This is a 2,000 watt braking resistor. You know, the measurements I've taken under braking are not anywhere near that. This will never meet its capacity. But you have two wires out to the braking resistor, two wires into the braking resistor. That's it. Very, very straightforward. The rest of the wiring, and this is where some people get a little confused, is simply to the on-off / forward reverse switch and to the speed pot. What I would suggest when wiring something like this is to get what's called LED cable. This is 18 gauge 3 or 18 AWG 3 wire, meaning it has 3 wires already in it. Now those may look teeny tiny, but I'm telling you what, all you have coming out of this to control is a 10 volt signal. It's not really any amperage coming through there. You're just sending a signal out, getting a signal back. So this LED cable is more than enough. I put my Huanyang, my VFD, and by the way, this is a 10 horsepower VFD, and I didn't buy 10 horsepower because I'm on board with, oh, you got to have more VFD than motor. I've never gone that route. It's just this is what was on the shelf at the time. This is a 10 horsepower VFD, and I mounted it inside this chopped up case out of a inverter that was at work that was being junked out, and that was just to keep oil and stuff off it, because I kind of wanted to keep everything up in this end. I did put it on back on a arm here so that I could turn this out. So gotta move some of that cabling out of the way, so that if I need to, I can turn this out like this and access all the electrical back inside. Okay. Back here, right there, I have my transformer. That's a 4,000 watt Diamond D transformer. And what I did was, when I brought my 250 volts in, I ran it through my switches here. There's one here and one here. One switch controls the VFD current, that controls power to the VFD, and the other switch switches to the transformer. On the back side of that transformer, see that green wire? I have a common ground point for everything, so everything grounds back to one point. There's a post back there. Everything grounds back to that one point, So I know where all my grounds are. And before I run through my switches, I also have circuit breakers. So I have a circuit breaker here, circuit breaker there. And that's it. You know, the power comes in, runs through the circuit breaker and switch. Some of the power runs to the VFD, and the other power switch runs it to the transformer. From the transformer, I have power running out to a 120 outlet here, which I'll show you here in a minute. 120 outlet here, and that outlet also runs straight up underneath the backside here, where I have the outlet for my light. I have a transformer in case I want to put 12-volt fans in, and the transformer also runs my coolant pump. So that's about it for the electrics. It's very, very straightforward. Okay, so my 3-wire, I've got 2 3-wire cables running out of this. One of the 3-wire cables hooks up, goes to my pot up here. Okay, and I have a small 5,000 ohm pot that controls the speed. Now, this was the original speed controller, and I have the original speed controller still functioning. But what I found out when I was putting this together was if I wanted to run that pot straight off of this shaft, that was taking something that's a precise piece of electronic equipment and running it into something that's not so precise. This hanger and that shaft, they're not what you would call precision. That shaft actually has some wobble in it. Any way you hold that pot onto that shaft would allow stresses to go through that pot when you turn the crank. I didn't want those stresses going on this. So what I did was I decided to separate the pot from the control. And the way I did that was I took this bar of aluminum and I ran a gear onto the original shaft here, and then that bar has another gear here. It's a 1-to-1 ratio, so that when I turn this, I'm turning this gear into this aluminum. Now this can all be doing what it wants. When it gets to this gear here, there's no stresses that can be put through that gear and that shaft to that pot. And on top of that, this bar, these aren't actually screws here, they're only screws on the back side. They're actually pins into the bar, so that if I move this, that bar is free to move back and forth, this way and that way. Okay, that allows any stresses that might be put into that as you're turning that gear to move the entire bar back and forth rather than bind the gears, which is really important. So I have a very, very smooth turning pot now. It's very accurate, very nice. I still have the stops, the original stops that came on the Monarch itself. So all the original controls are still in place here. A lot of allergies down here in Florida this time of year. Okay, the other 3-wire, which hooks in here, and by the way, when I say hooks in here, just look at the book. It tells you where to put all these wires. Very simple. It just goes into here and runs straight up through to the original control switch. And this is the original control switch that turns it on going forward, in my case, and reverse. If we come around here, okay, I've already started taking it out. To hook that 3-wire up on the original controller, let's get that out of there. Take the switch out here. This is the switch. Basically, I have power coming in here, and then going out to the VFD for left control and for right control. That's all there is to it. So as you turn that switch handle back and forth, you're just signaling that you want the motor to turn on and go forward or reverse. That's about it. So let me get that back together. I think about the last couple of things I want to hit on are the lighting and the pump setup for the flood coolant. So let's get these out of here. And when I took the breakers out of here, I simply installed a 120 outlet that allows me to plug my light directly into here, and when I get a DRO set up, I'll be able to plug straight into there. I bought one of these cheap transformers. I asked for a 15 amp. They only had a 20 amp on hand, so I got that sent to me. So I have 120 from the transformer downstairs running through the 120 outlet down there, and then up to this outlet, and then across to the transformer. The transformer runs power back down and out to this side to power the pump. Let's get down here and take a closer look at that pump. Now, this pump, we have coolant coming out through the sump. The sump is actually under here, under this plate right here, and it's divided. You have dirty coolant coming in here, or let's just say coolant that may contain chips coming in on this side. It's divided with a half wall, and fresh coolant hopefully goes over into a larger trough over here. I have a screen filter on the inlet to this, or the outlet from here and the inlet to there, to keep chips out of the line that comes in here. I extended this out so I had a drain, so the coolant comes through here through another strainer, and I can keep an eye on that to make sure it doesn't start getting dirty. And if anybody has ever owned a boat or an RV, you may recognize this. This is a 12 volt 3.5 gallon per minute pump for water, fresh water. And I've seen these pumps push ungodly nasty stuff through lines before on RVs and boats, and I thought, you know what, if it can push that kind of crap, that may be ideal for my lathe. And one of the reasonings behind that was, one, it was cheap, and in this case free. It was just one that had been left behind on the shelf, so I just grabbed her up and used it. And two, they have a built-in pressure shut-off switch. So let's say you're up here and you're running your coolant, and you decide you don't want your coolant to run anymore. Okay, shut her off completely. It backs up through the line, puts pressure on the pressure switch. It automatically turns the pump off. So anytime you're not actually using coolant upstairs, the pump will turn off, which is really kind of a handy thing to have. The other thing about it is that although it has a maximum 3.5 GPM rating, it will pump at lower amounts too, and it pumps slower. You can hear it when you're just trickling the coolant. It's just going tunk, 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 and then as it speeds up, you know, you're adding more coolant, it'll start running faster. So it works out really well for a flood coolant pump. Like I said, it's cheap. It works well. It will pump crud even if you don't need it to. And in this case, I got a 12 volter, which was fine because I already had the 12 volt transformer that I was going to use for cooling fans on the motor. Now let's get back to the motor for a second, because I really didn't talk about that. That motor is actually sitting inside the original Reliance case, and some people think, oh, that might be kind of hard to do, blah 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 blah, but actually it was dead easy. What I did was I just I took the whole case out. I had to take the whole motor out. In that instance, the back gear transmission is one with the motor. It doesn't come off separate. The input shaft to the 2-speed here is actually the shaft coming off the motor. It's the same shaft. In the original setup, if you pull the gearbox, you have to pull the motor as well. The whole thing has to come out, and that's kind of a pain in the butt, especially with a gearbox this old, that you may have to service separately. What I did was, when I had it all out, I chopped the shaft off the original Reliance motor. I used the original input shaft coming off the Reliance motor to input to the gearbox here, and it worked out really well. All the guts of the Reliance motor I took and threw away. This motor is coupled to the back shaft or the input shaft of this through one of those finger type connectors that just lock in like that. So when you pull that off, it just comes away like this. It just separates. It has a little rubber bushing in there. I forget what those couplings are called, but it makes it really handy for taking that gearbox out. The motor itself, that's a Century Gould 7.5 horsepower motor. It had feet on it that splayed out like this on the bottom, and what I did was I just ground the feet until that motor would sit inside the Reliance case, down at the proper position to where the shaft was dead center in the middle of the case. And it took probably an hour and a half to grind that and get it just right. And then I ran a piece of angle iron across the back just for extra support to bolt it to. And I don't know if you can see it, but if you look inside, I put some Visolastic rubber pads here on each side to stabilize the motor inside the case and take out any extra vibration. And I'll tell you what, it runs dead smooth. It really does. So getting that motor in there was only about an hour and a half. Putting the whole Reliance case into back into the frame here requires shimming it. Shimming it was dead easy. I had 6 shims, so I started out with 1 shim each on the front and 2 shim each on the back, and it was perfect the first time. And when I say perfect, I had perfect alignment in these pulleys top to bottom. Meaning the pulley here on the bottom wasn't canted in or out; it was straight up and down. So that keeps the belts aligned nicely. So I'm really happy with that. And after I did that, because the motor or the gearbox is separate from the motor, what I did was I made alignment dowels, and I just put alignment dowels in there, slid that in place, turned that until the coupler lined up, and then chunk, in place she went. Took the dowels out one at a time, bolted her in, and she's done. So getting it all hooked up was actually really easy. I should probably write this down, maybe put it on Practical Machinist or something. There's plenty of guys that have done this, so it's no big secret. So that's about it. I got the motor set up, the VFD, the pot in its own carriage here, the braking resistor. That's about all in there, unless you add that transformer. That's just an extra. That's just so I could have 120 volts on board, and in this case I also have 12 volts. Oh, that's what I was coming back to. The idea of the 12 volts was that I was going to install extra 12 volt fans in here. I've got a bunch of cooling fans that are 12 volts, but I've never been able to get that motor to run anywhere near hot, and I mean running the snot out of it, and I just cannot get it hot. So I guess the cooling on that original Century motor is really good. Anyway, so back around to here. I think I already talked about this, so we're good here. Let me button this up and then we'll take her for a ride. Down here, what we did was we took this panel and we turned it into a door to close up. It has a magnet down here that closes it and holds it tight. We put this door in here to cover up our switches, and as you see in here, we have a switch for the VFD, and then we have a switch for the excuse me, transformer. Both switches are on circuit breakers, so if we do overload them, of course we have that protection. Now, one thing I noticed about this Huanyang VFD is that it does not have a sudden inrush of current. So I really decided to just not bother with magnetic switches or anything like that. I didn't need any filters. I have nice clean power here. You know, actually I've never used filters on any of my VFDs and have yet to experience a problem. I think a lot of the forewarnings on that are for these countries that have a lot of fluctuations in their current and stuff. And I mean, there's guys that'll probably argue that point with me, but you know, if you go with something that works and it continues to work, it doesn't give you issue, then you know, why go through the extra expenditure to add extra things like filters and stuff in there. So this directly switched. These are train switches for air conditioners, 600 volt capacity, 40 amps. Easily handle the power requirements for both the transformer and the VFD. When we were bench testing the VFD, we had the power cord hooked to the VFD and we were just simply plugging it into the outlet. We didn't have any switches, and when we were doing that I was a little worried about inrush and power surges and stuff, and I threw an ammeter on there, and we had no spikes in power. We didn't have any sudden jump in current flow or anything like that. As a matter of fact, the Huanyang VFD has like a slow start to it. You can hear the relays click on in it, and then one thing turns on after another. It takes, you know, probably 30 seconds for it to turn on once you apply power to it before it's ready to go. So inrush, I'm not seeing it. The transformer power also runs the outlets here. I've got an outlet here and on the back, of course, which you've seen. I like having an outlet here in case I'm running a tool post grinder. I can keep the cord on this side, or if I want to have a vacuum cleaner or a Dremel tool or something, it's all right here. This is the switch that turns the transformer, the 12 volt transformer, on and off, which gives me power for the flood coolant and fans if I need them up the road, or anything else that I may want to run 12 volt on. The original start switches I took out, and I turned the diameters of the holes for the switches and brought them down closer to flush so I could install these lights. And this allows me to see when the machine is actually turned on. So let me turn the VFD on. Okay, see the green light comes on, and do you hear that? Yeah, exactly, it's dead quiet. That's why I wanted to have these lights, so that I'd know that I was powered up. I wouldn't walk away from the machine and you know, leave it running. This is the transformer down here. Turn that on. Red light comes on for that. So now I know I'm powered up at both points. The wires for those lights, I actually ran right to the component rather than from the switches, so that I know that I had power at the component. So if something torqued up, say my VFD didn't start up, I could see instantaneously that I would have power to the VFD. Then I'd know that the issue would more than likely be within the VFD. And that's something else I'd like to bring up about these VFDs. They are actually so cheap that it makes no sense to overthink them. You know, you do away with a lot of componentry within this machine, and basically you end up with a motor and a VFD. The braking resistor is nice to have in there as well. I put a 2000 watt braking resistor. That was way overkill for this machine. I've yet to get anywhere near 2000 watts jumping into that thing. But it's just nice to know. That I think is the real savior of a VFD, is a braking resistor. I'd rather have a braking resistor any day of the week over additional filters. So the VFD is actually so cheap that it makes no sense to overthink it. I've seen people write that the VFD, if there's a problem with it, it's complicated, blah blah blah. You know, for $250, $300, if it's complicated, if there's a problem with it, throw it the hell away and put another one in. It's not brain surgery. It'll cost you more to repair it than it will to do anything else. Anyway, so just showing you here, she'll spin right up quick like this. Back her off. I should probably put something in that chuck. I don't like running her freestyle like that, so I'm gonna put a piece of metal in there. Hey, maybe we'll clean that up on the end there too when we get done. So she'll run right up and she'll speed right up real quick, no problem. I hope I got that camera straight. She'll run right up, no problem. Just like that. And right now, to get to 2500 RPM, I've got her overdriven. I've got her overdriven by about 50%. And to bring it down to, what's it sitting at, 300 right now? 250, 300? Bring it down a bit. Yeah, about 300. RPM, it's underdriven by about 50%. It's maximum horsepower rating because of the differences in pulley sizes, the reduction. Puts the max horsepower at around 1600 RPM at the spindle, so I'm really running in my prime power zone between about 600 and 1600 as far as torque to power ratio. She's got nothing to give up on the old DC, that's for sure. She'll hump right along. And I don't have it set for a dead quick stop. I don't like that. I think it's hard on the components and I don't really need it. I'm not having to ever stop the spindle dead short like that. Reverse. Forward. No problem. And we can actually change the speed of this on the fly, just like that. A lot of guys are afraid to do that, but it never presents an issue. Low, medium, high. As long as you're not actually cutting while you're doing that, it shifts better under power than it does trying to rock the spindle back and forth. So don't ever be afraid of that. Medium, high. And it makes a difference if you're cutting on one piece of metal and you just want to speed it up, or because you're going another metal, or whatever reason you need to speed it up or slow it down. It's just a quick way to do it without actually having to come down and resetting all your feeds through here. The feed screw for the threading, I would definitely shut it down for that. I wouldn't do that under power. Of course, your speed handle here, this is to raise your speed up and down on the VFD. This is your back gear here. Pop that out, switch it to back gear, which I'll do in a second. And I'll put that back into high range so you can see that rolls along nicely. And this is for your cross slide, which is very nice. And you can change direction this way as well. Under power, of course. And this, of course, is for your threading. All works slick. The tailstock, nice and smooth now. I didn't think I was going to get it to that after it seized in place. I went with excuse me, let me turn that off. I went with the multi-fix tool post. I really like this. This is sweet. Not much to complain about top end. Everything works well. I'm really glad the VFD is in there now. It really makes this a utilizable machine. So let's just run a few chips here. I've got my chip plate on the back there. I'm going to set the camera up for that. Put my Rucker apron on here. It's funny because I talked to Keith Rucker there up at Florida Flywheelers the year before last. Asked him about his 10EE. I was kind of waiting for him to do his before I did mine. But I guess he's got better things to do. and he still hasn't got to it at this point anyway. Should be good on there. Cleans her up just like a pro. Just beautiful. Yeah, I mean, this thing is... Okay, had a slight interruption there. My neighbor has a couple of hillbillies that come around and cut his grass here once a week, and oh Lord, those guys make some noise. Anyway, so back to this. Just a little cutting action there. I have some upcoming footage. I'm actually doing some projects on this lathe. Probably you noticed from when I started filming it to now, it's gotten pretty filthy, and that's mainly because I had to stop in the middle there and I was working on something else and come back to this. So I hope you like what I've done with this, and I'm particularly talking to my brother Jeff. I hope you like what I've done with this. I love using it. It's dead accurate. I don't even really hardly miss having a DRO on this. By the dials alone, I can easily dial it into a thousandths, and if I'm off in the 10,000ths, the tenths of a thousandths, it's more due to, I think, parallax error looking at the dial. And if I get that fussy, you know, I need to put a dial indicator on there anyway. So I guess that's about it for this video. Jeff, thanks a lot, and from Florida, Don out.